Okay, welcome to today's course, and in today's course I will be discussing how to write the method section of a theoretical paper. Now, a lot of videos on YouTube online discusses the method section of an experimental paper. So you'll find such things like materials and method and setting up experiments and all of that, leaving behind those of us who write theoretical papers to a deficit of tutorials on how to put together a theoretical paper. And before we get started, I need to explain to you that a theoretical research paper is a type of an academic paper that focuses on developing and testing theoretical frameworks, models, or concepts to explain a particular phenomenon or issue. It leverages on analytical technique, computational techniques, or simulation to verify or dig further to fundamental issues that are common in the STEM fields: physics, chemistry, biology, geography, and geology, or the business fields like economics, data analytics, financial modeling, etc. And so, how does the method section look? How is it different from the method section of an experimental paper? I will take you through a number of theoretical papers, and where you'll get to see the concepts of the method section and the whole lot of mathematics, and how you could break these concepts into very simple, manageable parts. Get to the method section of a theoretical paper such as this one. There are a whole number of things you find. First, you find an attempt to explain the mathematical framework and the assumptions made. Next, you would see a whole lot of mathematical derivation, definition of parameters, and some justification of these parameters. And this is not just common in papers in physics. You could also find almost the same thing when you explore papers in economics like this. This is a research paper in economics. It also opens with a brief theoretical background of the theories and equations set up in this paper, and it would progress to a solution for the different theories developed. And the method of solution may be a simple computational method, or a complex analytical method, or a use in a simulation method where you will discuss the computational tools used. It also can be found in a chemistry paper, in a chemical engineering paper, and like every other theoretical paper, it would open with some description of the theory, perhaps a diagram that gives a pictorial overview of the theory to be used, and it would go down to invoke a particular mathematical theory, and the significance of each of the parameters in that equation would be explained, and how it relates and reflects to the physical phenomenon that is modeled. Now understand that a theoretical paper attempts to model a physical situation. Yes, that is the purpose. That is the whole concept of a theoretical paper. It models a physical situation, and so it wants to dig up mathematical equations that properly represent a physical situation, like climatic change, like the optical properties in a quantum dot, or the flow of fluid through the body veins, or the variation in the price and purchasing power of an economic policy. All of these can be modeled mathematically, and that is the core of a theoretical research paper. And so, in a general conception, what are the components of a theoretical paper? How do I get to write a theoretical paper? I will be taking you one step at a time to the components, then how you get to put out and write a beautiful computational paper. Let's get back to it to discuss first the components, then how we get to write it. So first, what are the components of the method section of a theoretical research paper? The first part, the first component is the system description. This is where you describe the features of the physical system you are trying to model theoretically. Say the system is like a quantum dot and it is spherical in nature. It is where you describe the radius and the significance of the radius to your model. It is where you describe the eccentricity, if it is some ellipse or some spherical shape that deviates from a normal sphere, or it is a cylinder like the veins in the human system or the animal system, the veins and the arteries that are cylindrical in nature. You want to describe the physical system, and next you want to from the description of physical system, put together mathematical formulation that exactly, almost correctly model this physical system you're modeling theoretically. So the second component of the theoretical section or the method section of a theoretical paper is the mathematical formulation. The third part is the solution techniques. Now, in the mathematical formulation, it's where you pull out or invoke a particular mathematical principle, a formula, or an equation that models the physical system theoretically. It could be as simple as Hooke's law or as complex as the Schrödinger's equation for a nanostructure system, or it could be the Navier-Stokes for a fluid system, or it could be a partial differential equation, or even the ordinary differential equation, or it could even be a simple integral calculus that effectively models the physical system you are trying to theoretically investigate. The third component of the method section is the solution technique. Now, after you've put out the mathematical formulation, you want to put out the method of solution. You want to tell us, this equation we have put out, we're going to solve it analytically. We're going to solve it by computational method, maybe the forward difference method or the backward difference or the finite difference method. We want to solve it by method of simulation. Is in the third part of the method section that you list the solution technique you wish to adopt in solving the formulation, the equation you have put out in the model. Then the fourth part is parameter definition. Yes, tell us that arrow in this equation is the radius, A is eccentricity, D is diameter, phi is density. You want to correctly explain and define every mathematical symbol, every parameter you have put out. Not just explaining them. You want to tell us their significance in the equation. And number 5, the fifth part, the fifth component of a theoretical papers method section is the boundary conditions and the assumptions you are making. Oh yes, some systems cannot be perfectly modeled, and so you get to choose an idealistic model so that mathematically we can put out some equations to them. And so these assumptions you make, these boundary conditions you decide, you need to state them at the fifth part of the method section. And number 6, finally, you validate and verify the method. How do you get to do that? It is in this section you cite similar studies that have used the method you're using. It is in this section you justify the approximations you are adopting. It is in this section you mention justify the solution method. Why have you choose to use analytical method? Why are you using the computational method? Why are you solving this using an algorithm in Python or in R? Why are you getting to solve or tabulate or compute the values you have raised using MS Excel? It is in this final section you get to cite and you get to justify and you get to validate the principles and the methodology and the assumptions you have made. Now, after you've known this 6th section, how do I get to write it? How do you get to write the method section? How do you piece this information together to create a very informative, a very duplicable method section? Now, these are the 5 steps you need to take to write. First, you identify the system. In writing the method section, the first thing you write is the identification of the physical system. This is where you describe the physical system, the chemical ability, the biological system, or the mathematical characteristics of the particular system you are trying to model. Number 2, the second part you write, say the second paragraph if you like, is where you highlight why the system is important for study, both fundamentally and in terms of application. Why you're going to study the system in this order. Why have you choose to study the system as a sphere? Why have you choose to study the system as a cylinder? Why are you choosing a random method to study this particular system? And so you explain the significance. Number 3, you write the problem statement. That is, you outline the specific phenomenon or property being studied within the system. You're not studying everything in the system. You're studying eccentricity, or you're studying the variation of the radius, or you're studying the variation of the length, or you're studying the effect of heat or magnetic current or magnetic field upon that system. So you define exactly which system or which part of the system you're studying, and next you introduce the mathematical foundations, the equations, Navier-Stokes or Schrödinger's equation or Hooke's law or Henry-Bloch's principle. Any principle you're studying, you need to put it out, and next you establish the theoretical approach you're going to use to solve the equation. And when you're done with that, these are of course the 5 things you need to do in putting out this section. Now, just for that to explain further, you present the equation and parameters concisely. You provide explanation for deviations, derivations, linking equation logically. You link parameters to the physical system. You make a logical progression to solve the equations that are developed. Now, in describing the solution, you begin with detailed steps, then you move to the assumptions made, then you cite sources, then you establish some boundary condition. In validating the method, the methodology, you cite other studies, you justify deviations from the other studies you've cited, you mention the tool used for computation, and you mention the values of parameters assumed. Now let's get to see a typical example of how all of these components are used in the method of a particular paper. This is a typical theoretical paper that investigates the effect of eccentricity on magneto-exciting dynamics in an ellipsoidal quantum dot with a screen Coulombic potential. Now let's quickly get to the method section. And in the first part of this section, you see a description of the system. Following that, you find some equations that is going to be used to model the system and the assumptions made. And of course, you're going to find the introduction of the Schrödinger's equation that effectively models the system. And you're going to find some assumptions made, and you're going to find method of solution and how the technique used to solve. Of course, somewhere here you're going to find the justification of the method and a reference to other studies that have used this same method. And that is an example of